Question 3, chapter 6 and 7. Assume that the output per worker production function is yt equals 2 kt raised to 0.5. The savings and depreciation rates are estimated to be 0.1 and 0.02 respectively. Then the question is, what is the steady state capital to labor ratio for this economy? What is the steady state capital to labor ratio? Capital to labor ratio is KT. So they're asking us to find KT, right? And the way we can find it is by equating the steady state, right? The steady state equation is basically when depreciation equals savings or investments, right? When that happens, we know that this is steady state. If you remember from the video that I have for this chapter, chapter 6, I've actually covered this in quite a bit of detail as to how do we build this intuition as to at steady state depreciation equals savings / investments. So once we know that intuitionally, once we know that, we can write the formula. So depreciation formula is delta times KT, and savings / investment is savings times the output, and output is AKT raised to alpha. So once we know this, we have all of the things given. So y equals output equals AKT raised to alpha. A is 2, which is from this equation, right? A is 2, alpha is 0.5, y is output, right? And savings is given as 0.1 right here, and delta depreciation is given as 0.02. So once we plug all of that in, SKT equals delta KT equals S2 KT raised to 0.5, then we can solve for KT. There's only one variable here. So then KT equals 100. So output capital labor ratio for the economy is 100. So there's 100 units per laborer. KT is output base, so capital labor ratio is 100. So building on, we are given the same production function, and now we are asked, like, what is the steady state consumption per worker for this economy? The 3.1 was steady state overall. Now in steady state, what is consumption per worker? We were asked for capital labor ratio first. So now we know capital labor ratio, and consumption is nothing but output minus savings. Whatever you produce minus your savings is you consume that, right? So if we do that from question 3.1, we know KT is 100. So we plug that KT here in this equation, we get output, right? So output YT equals AKT raised to alpha, right? Actually, this is not correct. This should be 0.5, right? This should be 0.5. Let me see if I can change it right there. This is 0.5. Yeah. And so output would be AKT raised to 0.5. So YT equals, so this is square root of 100, right? So yeah, so YT is 20. So output is 20. Now savings equals savings rate times output, right? We've given the savings rate of 0.1 times output. So 0.1 times 20 is 2. So that's savings. So the consumption now is output minus savings. So it's 18. So that's how we arrived to this, right? So I've highlighted this again. All of this assumes that you understand this chapter 6 that I've covered on YouTube, or you've read chapter 6. If not, you will not know what output equation is, you'll not know what depreciation equation is, you would not know what savings equation is, and you would not know what this thing is, the steady state. So this requires you to know some of these concepts. Yeah, thanks.